I welcome all of you to this night's program, JAB Online Lecture. So, I just want to beg you, please get all your materials ready and get ready for the class. Prepare all your questions after the class, then send it to us straightforward. We're going to solve them. And also, I want you to keep on updating yourself with us. We keep on updating you as well. So, and don't forget to send your question. We are going to respond. So remember, you can also mail us at fatherchemistry@gmail.com, fatherchemistry@gmail.com. And also, you very soon you have the grace to watch us on YouTube, and at the same time we'll be doing watch party on Facebook as well. So you also have the grace to join us there as well. Don't forget. So tonight we are going to the topic you see here. The topic we are seeing here tonight is what is called balancing of a chemical equation. Balancing of a chemical equation. That is what we are going to do tonight. So now, based on this topic, balancing of chemical equation is very, very important. If you cannot balance a chemical equation, it looks as if you are a partial chemist or a student of chemistry. If you cannot balance a chemical equation, because balancing of equation is one of the reasons why chemistry is in existence. Yes. So now today, let us quickly go to the business balancing of chemical equation. Now in this place, what you'll be seeing here today is a formula. You'll be seeing a formula symbol and numbers. That is what we are going to see all through this night. Formula, symbols, and numbers. That is what we are going to see. Now, in most of the chemical equation, remember we always have what is called the reactant and the product. Now, for instance, when we have A plus B to give rise to C plus D. Now, if you look at this example that we have here, now this is A. We have A and B reacting together to give rise to what is called C and D. Now, in this expression, what does that imply? This means this is what is called reactant, while this one is called products. Reactant and products. Now, in this equation that we have here, you can see that there is no number, there is no any other things pertaining to this equation. So it's a clean and a clear equation. Now, but what we'll be looking at tonight, remember I said we have reactant and we have products. So we are going to start it from one angle. We pick it one after the other. Now, if you want to balance a chemical equation, it is easy to balance a chemical equation. But I want you to know that here you can use a try-error method. So to get what you want. Now, let us look at this example here now. In this place, for instance, let us look at e.g., or let me say example 1. Let's take note, example 1. Now, for this example 1, we have SO2 plus O2 to give rise to SO3. Now look at the equation that we have here. We have SO2 plus O2 to give rise to SO3. Now in this equation, we normally have what is called before the reaction and after the reaction. So I will teach you the way of doing that one. Now let's look at before the reaction. Before the reaction, what do we have? Our X in this place is equal to 1. The total number of O here, 2 plus 2, will give us 4. Also in this place, our S here is equal to 1, but the total number of O here is equal to what? Is equal to 3. So this one, if you see the number of O here is not balanced. Why? Because it is 4 here and it is 3 here. Now, if you now want to balance this equation, then what do we need to do here? Now let me write the equation again. So we are going to have SO2 plus O2 to give rise to SO3. Now, remember, when you are balancing a chemical equation, you don't have anything to do with the atom. Take note, you don't have anything to do with the atom. If you want to add anything, you want to add any number, you only have the grace to come here and add number here. So that the place that are available for you to add number here, and in all three, in all equations. Now let us now begin. Now in a given equation, one is either from the product side or from the reactant side. This is the reactant, this is the product. We always give you the clue of where to put your number. Now let's look at this one. Now we have 3 here. If we have 3 here and in this place we only have 2, then let us look at this. Why can't we come here? Why can't we come to this particular side now? Because we are going to look at where we can put the number so that the equation can be balanced. Are we together? Now if you see the number of s is 1 in this place, now let's check it out. If we come here and put 2 here, let's see what will happen. 2 times 2 in this place will give us what? 4. Then plus 2 here will give us what? 6. That is to tell you that the number of oxygen, the total number of oxygen in this place is 6. Now if that is 6, then let's come here and balance this one with 2. If we balance this one with 2, let's check it. 2 times 3 will give us what? 6. Now in this place we said that 2 times 2 will give us what? 4. Then plus 2 here will give us what? 6. Now that means before the reaction, that should be after the reaction. What do we have? After the reaction, we have our x is equal to what? X is equal to 2. The total number of O in this place, 2 times 2, 4, plus the 2 here, we have what is called 6. In this place, our x here is equal to what? Is equal to 2. Now, in this place, for the total number of O, 2 times 3 is equal to 6. That means our equation is balanced. You can see S to S and O to O. So this equation is balanced like this. So take note of that. Take your time to write the equation. Now I have example 2 here. Now in this example 2, we can see what we have here. We have iron reacting together with water to give rise to Fe3O4 plus H2. That is the product that we have here, as you can see in the equation. Now let us now look at how the equation will go. Now in this equation we can see that the number, let us say before the before the reaction, or let's say before balancing, what do we have? Fe is equal to 1, H is equal to 2, O is equal to 1. At the reactant side, at the product side, we have Fe is equal to 3, O here is equal to 4, and H is equal to 2. So you can see that the equation is not balanced. Now, if the equation is not balanced, how are we going to do this? How are we going to balance the equation? Now, to balance the equation, now this is what we are going to do. Now, we look at it one after the other. Now, look at the O that we have here. Let us write the equation. Fe plus H2O to give rise to Fe3O4 plus H2. Now, if you look at the equation that we have here, now, for the number of O here is 4. The number of O here is 4. So, if the number of O here is 4, and the number of O here is nothing, and I've said it earlier that you don't alter the atom. So, at the reactant side, let us come here and come and put 4 here. If we put 4 here, let's see what will happen. If we put 4 here, that means 4 times 2 will give us what? Will give us 8. If the number of hydrogen here is 8, then what happened? Then let's come to this side and check this one too, because we have to make everything to be balanced. Now, 4 times 2, 8. Let's put 4 here too. 4 times 2 will also give us 8 as well in this place. Let me just tell you something. you can start with the lowest number, but I'm telling you that if you have to start with the lowest number, it will take much time. For instance, now maybe we should be doing try, let's put 1 here, let's put 2 here. No, we don't do that, because at this level I believe that one should be more matured in anything that you are describing. Now if this one is 4 in this place and this one is 4 here, then we can say that the number of h here is equal to what? 4 times 2, 8. If that one is 8, the number of o here is what? This 4 is affecting everything, it's also affecting the o, so o is equal to 4 here as well. Now in this place, f is equal to what? Is equal to 3. Now we just come to the back and put 3 there. Then if you put 3 here, definitely our f here is equal to what? Is equal to 3. Now this is at the reactant side. Now at the product side, let's see, fe is equal to what? 3. Number of o here is equal to what? 4. Number of h here is equal to what? 4 times 2. 4 times 2 is equal to what? 8. Now the equation is balanced. Please take note, you don't add this, you multiply them. 4 times 2 will give us what? 8. Take note, 4 times 2 is also what? Is also 8. Take note of that. Take note of that. So now let's look at the equation. Is it balanced? We have 8 here, we have 8 here, we have 3 here, we have 3 here, we have 4 here, we have 4 here. That means the equation is balanced. So we are going to call this one after balancing the equation. After balancing the equation. So that is what we have there. So take note of that. Take note of how the equation go. Take note of how the equation go very well. Very, very important. So the equation is balanced like this. Take note of that. Now I would like us to look at another equation. So the equation that we are going to check now is going to be with those of organic compound, organic equation. So for instance, when we are talking about organic compound here, we are talking about those that contain carbon, hydrogen, and oxygen. So carbon is the chieftain, is the chieftain in that particular place, the carbon, because of its catenation ability. So, but under the carbon, we'll be looking at some of the reaction that you can come across. For instance, let us quickly look at this reaction that we have here. Now, the equation is C2H5OH plus O2 to give rise to CO2 plus H2O. They will now label this one X, Y, and Z. Now, the nature of this question resembles that of a JAMB question. This is how JAMB question normally come. JAMB question, this is how it normally comes. They will ask you what is X, what is Y, and what is Z respectively. X, Y, Z respectively. They will ask you to find them. Now, when you are asked to find X, Y, and Z, then there is something you need to do there. It means you have to balance the equation. This is common way of expressing JAMB question. And looking at this equation, you can see it is oxidation, and this process involving production of what? Of carbon dioxide and water. So it's a combustion reaction, and this is what is called ethanol. You can see. So this is what is called ethanol. Now, the oxidation or the combustion of ethanol gives rise to carbon dioxide and water. Now, let us look at how to balance the equation. So, on this compound, we'll be looking at this one as example 1. Now, if that should be the case, then let's look at how it goes. Remember, this is organic compound. Organic compound. Now, let's quickly balance the equation and see. So before balancing, what happens? C is equal to what? C is equal to 2 here. The number of H here, let's say the total number of H in this place now is equal to what? Is equal to 6. the total number of O, the number of O here is 1, the number of O here is 2. So that means 1 plus 2 is equal to 3. Now let's come here. C here is equal to 1. O here is equal to, the number of O here is 2, the number of O here is 1. So that means 2 plus 1 is equal to 3. The number of H here, in this place, we just have only 2. Now, if that should be the case, then the equation is not what? Balanced. So, then to balance the equation, we write the equation. So, we are going to have C2H5OH plus O2 to give rise to CO2, then plus what? H2O. Now, to balance this equation, one of the products or one of the reactants can give us the clue of what we want to do here. Take notes. So, now, in this place now, let us look at how it goes. Is there any one of them that is balanced from the beginning? No, none of them is balanced. Then we now look at how we are going to go into the business so we get what we want most. Now, in this place, the number of H here is 5. If the number of H here is 5, the number of H here is just 2. Okay, if that should be the case, then if we put 2 here, 2 times 2 is equal to 4. If it is 4, then what have you done? 5 plus what? Plus 1 is equal to 6 in this place. So it will not give you what you want. But the number of C here is what? Is 2. The number of C here is what? Is 1. Then let us just try and put 2 here and see what we are going to have. Let's put 2 here. If we put 2 here, this 2 here is affecting the C, is also affecting the oxygen. So in this place, we can say that 2 times 2 of this one will give us what? Will give us 4. If 2 times 2 of that one will give us 4, then what happened? The number of O here is what? Is 1. The number of O here is 2. And we don't have anything here. Then we can come to this side again and check where we can also put another number. Let's check. In this place, we have 2. Then let us try and check, because we know that the number of O here now is 3. And the number of O here as well is also 3, as we can see. But now let's put 3 here and see whether it will go. We can't put 2 here, because if you put 2 here, you'll not be able to get what you want. Let's put 3 here and see whether it will go. Let's put 3 here. If we have 3 here, 3 times 2 will give us what? Will give us 6. Plus 1 here will give us 7. Then 2 times 2 here will give us 4. If that is 4, remember the number of oxygen here is 4. But we made mention of the total number of oxygen here is 7. Then let's come here and put 3 here. So that 3 times 2 will give us 6 plus 1, 7. So that for oxygen here it will be 2 times 2 will give us 4 plus 3 will give us what? 7 as well. Then let us now look at the number of hydrogen, whether it's balanced. 3 times 2 will give us what? 6. The number of hydrogen here, hydrogen is 5 here, plus 1 is also what? 6. Now let's check whether the equation is balanced. So that means after balancing, what do we have? C is equal to 2. The number of H here is equal to 5 plus 1 is equal to what? 6. Then the number of O is equal to 3 times 2, 6, plus H is equal to, plus O here is equal to 7. So yes, C is equal to 2, as you can see. O in this place, 2 times 2, 4, plus the number of O here is 3, is equal to 7. Then the number of H is what? 3 times 2 will give us 6. 3 times 2 is equal to 6. Now, is the equation balanced? Yes, it's balanced. You can see 6 for the hydrogen, then 7 for the oxygen, and 2 for the carbon. So that is that one there. So in case if you have any question, you can forward it to us. So thank you very much. Thank you. I really appreciate your cooperation with us. Also, very soon we will be having the access to watch us on YouTube So take notes. Thank you very much. Don't forget to mail us. We like any forms of criticism from you. Thank you very much.